Hello everyone, it's Sean from Having Fun Repairs and welcome back to my channel. We're actually going to start here shortly on a new restoration series. As a matter of fact, let me get my big head out of the way. And I'll put myself up in this corner over here. It's going to be on this radio receiver you see on my desk, on my workbench here. This is a Zenith radio from the late 1930s or early 1940s. Model number 5D810Y. I'll get into a little more details on this radio during the restoration of it, but if you can't tell by the amount of dirt and everything on it, and the amount that's leaving on my desk, I think I got my work cut out for me. Let me set this aside gingerly, because I'm a redhead. Now, I've worked on several radio receivers throughout my career, but mostly transistor-based radios and in the UHF and VHF spectrums, very few in the HF. This radio, however, is strictly in the medium wave band for commercial reception, your standard AM radio frequencies, I guess. If I can put it that way. It's also a tube-based system, which, if I'm being honest, from me to you, I've never worked on a tube-based radio. So that being said, this video is not going to necessarily be about the radio and starting the restoration on it, but the test equipment or safety type equipment that we need to set up before beginning working on this radio. And that will come first with a isolation transformer. I'll throw a picture up here in this left corner, and a Variac picture over in this corner there. And then building ourselves a current limiting device, something called a dim bulb tester. Now, like I said, I've never worked on a tube-based radio or myself, but there are plenty of YouTube channels and folk out there that have shared this type of content. So I figured I'd just give it a try myself, and also just kind of present myself a challenge, something I haven't done before. So the first thing I'd like to tackle, since it's going to take up the most amount of time and has to be built and wasn't bought, is our current limiting device. We're going to build our dim bulb tester. I went to my local hardware store, Lowe's. Little receipt here, how much all the items cost, and we'll start out with the these 3/8-inch plastic cable connectors. These cost this package costs $4.48. 8-foot 16 gauge 3-prong wire. We're going to use this to electrically connect everything inside of our dim bulb tester. It cost me $9.88. Our 2-gang duplex receptacle cover, $2.32. And the box we're going to use to house everything, $10.78. I got this little GFCI outlet tester, not to test any GFCI, but because I wanted the voltage measurement device on it. So that way when we adjust our Variac, this could get plugged in at a receptacle and tell me what my actual voltage is. I don't care if it's, extremely accurate, but it needs to have some good accuracy. So we'll compare this voltage measurement with our fluke meter and just see how accurate it is after we build. We also have this Eaton combination power switch / receptacle. I'm going to need this in order to disconnect power from our test box as we build it. Act as an on-off switch. Our The bulb will go into this lower receptacle. Also have this 3-prong dual plug receptacle. The top one is where this cobalt outlet tester is going to go into, and the bottom one will be where we plug in our radio, the device under test when we power it up. And then let's see, the Eaton receptacle costs $3.08, and this 15 amp 125 volt receptacle here cost us, what is it, sorry, this one costs $8.07, this costs $3.08. Okay, and then we have this 600 watt outlet to socket adapter. This was relatively cheap, costing $2.14. And so long as I didn't just break it, whew, lucky me. A nice incandescent bulb, 150 watt G bulb, crystal clear. You need to use an incandescent, not an LED, not any other type of bulb when building a dim bulb tester. This is going to act as our current limiting device. Anyways, this bulb was $3.58. So let's do ourselves a little schematic, and then we'll get to building. Okay, to start out with, we're going to take our workshop cord that we bought, and we will feed it through the top part of this 2-gang outlet box. I'm going to put that cable restraint in the top so it can go in and then not be pulled back out. But moving on from that, and we'll trim this up and do a bit of, have to cut the leads and tin some new leads, etc. But here will be the basic setup, how things will be wired inside the box. Alright, so AC coming in from the top. I have a little key over here. Ground is green on the cable. There goes our green right there. I don't have a green Sharpie, so I wrote gold is going to be the gold Sharpie color on our diagram here. Neutral is white. That is this copper wire here. Neutral on the receptacle is going to be on the left side. That is the bigger side. And because I don't have a white Sharpie marker, but I do have silver, I marked it as silver. And then our hot is going to be black. That is this copper wire right here. And the hot is on the right hand side. Okay, just for a brief overview and understanding. Now, the first thing we're going to do is we're going to wire up our neutral. Neutral coming in. I'm going to terminate the neutral to here. And then I'll also have a neutral jumper from the hot bottom on this side to our switch up here. I'll get into why that is in a little bit. Now, one thing that we have to do is we have to break off this tab. So I'm going to have to get a pair of pliers and break off this break-off tab in between the hot termination lug here and this hot termination lug here, so these will no longer be connected. Okay, and then I'll bring in my hot from the top, and it will go here, and then another hot will go from the bottom of our hot here to the neutral over here. And then last, our ground will be running ground to here and ground to here. Okay, so that is going to be the setup. I'll probably take a photo of this and upload it to the Google site. If anybody wants to pull this diagram from off of there, you're more than willing to do that. But for now, I am going to get to building. Now that I have this somewhat put together, minus the faceplate and some other things, we're going to run some quick checks. First one's going to be a continuity test of all of our grounds. So while touching the ground lead on my plug here, I should have ground to these tabs, as well as internal on these plugs. And I do. The next thing I need to do is I need to check my neutral. So I'm going to try to use these tweezers. Put down to this receptacle. Probably not the best way to do this, but it is the way I'm choosing. Okay, hopefully that's shorted out. Now, I need to be able to test from the neutral lead. That is going to be this side right here to here, and I should get continuity. And I do. Now, also with this test, no matter with the switch in the off or on position, my neutral should always be connected. Next is going to be the hot. Now again, I'm going to short out inside this plug. And now I'm going to go to the hot lead. That is the far right lead. And plug this into my hot. With off, there shouldn't be continuity. With on, there should be. Okay, let's try that again. Off, on, off, on, off, on, off, on. Now if I remove that short, it should also disappear. So if all these test good, we should be good to go. Now that I've done this, I'm going to go ahead and say I actually got this set up particularly from the channel Flux Condenser, Vintage Audio Electronics. I was looking up dim bulb current limiter setups, and I found his most interesting and figured that is the one I'll use. So I'll put a link in the description below concerning this test setup. Now, one thing I do want to note, the difference between his setup and mine is he came through the top, and originally I was going to do the same thing, but I decided I would actually like to wall mount this guy near my isolation transformer and Variac, so I can have a wall mounted test device. This cable retainer that I put in here, it doesn't actually clip in as well because I'm using a different box than he is. So I'm probably going to use some kind of adhesive to get this to stay. But other than that, I'm pretty happy. Now that being said, you will never use this for powering any device. What that outlet is going to be used for is solely for your light bulb. Because the only thing it should do is allow current through when the light bulb is screwed into this socket. Now I also want to state that we have to be careful the type of bulb we use in our to limit our current. Okay, more particularly the wattage rating for the bulb, whether it's 100, 150, or 200. Now the reason for that is because our device is going to plug into here, that is the device under test. We have to be concerned with load sharing between this bulb and the device under test. And as I will turn up my Variac to increase the voltage coming out of our receptacle for the device under test, I want to ensure that the device under test is receiving the line voltage it needs, and that this bulb is not at a wattage low enough to where the voltage is kind of spread across both, and I can't get the input voltage for my device under test. Now there is another YouTube channel. Not sure how active this guy still is, but he goes over this, and I will link his video into my channel as well. But that is DVR Productions right here, and the video is isolation, transformer, variacs, and current limiters, which comes first. Very intelligent guy. Highly encouraged to watch his video as well if you're going to do anything like this. That being said, I think it's time for me to take this guy out, and I'll finish putting everything else together, and we'll plug it in and test it out. Now I realize this is a bit of a kind of a mess, but to test this, let me show you the setup. I've got my dim bulb tester, which I've now labeled on and off, meaning off is on this side and on is when it's flipped over to here. Probably should have reversed that just to make it a little more clearer, but there goes off on the switch. Here goes on the switch. Anyways, bulb for bulb, load going to this antique looking radio, which is really not an antique. This is a transistor radio, a Thompson collector's edition. I think it's model number 618, styled in a cathedral style radio, but this is a transistor based radio. It's a replica of an older radio. There goes the one that we'll be working on. But anyways, this guy works. I might give it a service at some point, but it works perfectly fine. But anyways, our load is plugged in. Our inline voltage tester, voltmeter here on the top. This is going to our Variac, which I'll turn completely counterclockwise for now. Currently powered off. And then from our Variac into our isolation transformer to the wall. Now, how do I know that this transformer is isolated? Well, I test from the plug in the wall between neutral on that to neutral at this socket, and nothing is connected. There is no continuity. Same thing with the hot. Hot on the plug, hot in here. I think I already had a video demonstrating that. No continuity. So this is fully isolated. So now I should be able to... Oh, one last thing. There is an external ground. Now, the ground does not go to this bottom third prong. It just grounds the chassis of this. I did connect that ground. I have it going down underneath my desk and to my third wire home ground that I made myself with a grounding rod I put outside my bedroom. If you follow that blue wire out all the way around, and then buried in the ground outside is a nice copper rod. I drove into the ground out there. But anyways, we should be able to power this on, and we have power there, and then we should be able to power this on, and that's not powering. What's going on here? You know, no power out. Let's check that real quick. Oh, LED's on, but yeah, I'm getting Nothing out there. Nothing out the plug. And I think I'm going to have to take this apart and find out what's going on. My isolation transformer might be broke. Well, for this demonstration, we'll bypass it for now. I'll just go Variac or variable transformer, but Variac to the wall and bypass this isolation transformer just to demonstrate this, and then I guess we're going to have a little mini sub repair video, and I'll be taking this apart and figuring out what's going on with that. Okay, so I bypassed this for now. I've put the Variac directly into my AC outlet down there. Alright, and I'll tear this apart. We'll troubleshoot it here in a second. But that's now in. Off. Move the radio up here. It is off as well. We're going to turn it on. And look, we do get a little display readout there. That's cool. Currently showing all zeros. We'll turn this guy on. Alright. And then we'll start powering this up by turning up our Variac. I want to get up to let's bring it up to about 100. Oh no, let's see, around 40. I start registering 38, 39 on here. Let's bring it up. Okay, so we're at 70, 71. I'm at 70 on here. I'll bring this up to 115. Well, at 115 on there, showing 114, 115, 116 bouncing around there. Okay. Now if I turn this off, you'll see that power is killed. We'll turn it back on. I would say that is fairly accurate. We'll turn on the radio.
Didn't really get it together, and so they eventually moved to Hunter Elliott, a freshman, who's just been phenomenal, and Dylan DeLucia. And once those two got in position as our first two guys on weekends, really made a big difference. And we lost Kevin Graham, who's an incredible hitter in the middle of the lineup with a broken hand for about a month, and didn't have anybody to really protect Elko. And when we got him back and he got back up to speed, we really started playing a whole lot better. And defensively, too, we were weak in the first year.
Yeah, I would say this is the setup's pretty good, and this is showing me 2 yellow, which means that it is wired correctly. So yeah, we're definitely good there. Now we gotta troubleshoot that guy. Yeah, so I'm pretty happy with that mounted up on the wall. Went ahead and just reverse that, so even though that says on the switch right there, I'm an idiot. I realize that the switch hides whatever position it's not in. So the pole this way being towards on, and now I would make myself less confused. But anyways, just wanted to do a voltage comparison real quick. Turning up the AC. So I'm going to stop first at 60. And we're showing 5960 up there. Okay. Let's go even higher. Let's go up to 120. Let's go up to 130. 130. Showing 131, 32. So it reads a little higher. up there. Let me turn it down to 120. 115, 120 is predominantly where I expect to be setting my output voltage to when I have a device under test, other than this multimeter plugged into here. But 120, 121, 122, and this is hovering really steady at 120.1.2. So you can see you've got a, what is that, 2-volt swing positive primarily, unless if one's the median, and then it's a plus or minus 1. So not as accurate as a flute meter, but I think that does suffice for what it does. However, I'm kind of not like using that, because when I'm working and I'm going to be sitting down in front of this radio, I don't want to stand up just to read that guy. So I'm more than likely going to get that Amazon little voltmeter insert readout thingy, where it just shows you your voltage right on the front. Little voltmeter you can plug into an outlet. It's no different than what was on FC's webpage or YouTube channel, going over how to build this thing. But anyways, here's what it is. I guess it's time to break open the isolation transformer, find out why it's turning on but no outputty power outy putty. Went ahead and put the isolation transformer on my desk. Had to remove that ground tab. It was screwed in right on this side. So here's to only have 4 screws total, 2 on each side, and then this upper shell should lift off. Nothing too serious. You figure out why I got no output, as I previously stated. So nice beefy transformer. And I think I just discovered the reason why. Hold on a second. Let me see if I can pull my head cam down here. Will this reach? This might reach. If you already notice it, go ahead and throw it in the comments there. Turn on this head camera. Bring it right on in. Looky, looky. Fuse holder is kaput. Completely broken. That's interesting. But there you have it. The whole reason. It's no worky. Because of broken fuse. Let's wire it up. AC power comes in, goes through the switch. Looks like we have the main side of our transformer input, but then fused output. So that makes sense to me. It was the fuse side of the output heading to yeah, whatever. I think y'all understand what I'm saying. Took a day off to order some things. It came in within a day from Amazon. A new fuse holder, Blue Sea Systems, water resistant, 20 amp max. think this one will work. The measurements, the dimensions seem to be about the same. So maybe just slightly different. This one's got a screw tab. The old one has a screw-in style cap. This one is twisty cappy. Alright. It should work. Should work. Then set that over there. 3-pack of these little plug-in digital voltmeters go right into an AC socket, and you get a readout on the front. So no different than the recommended video I gave to y'all. Thought I could just make do with that cobalt tool, but even though it is nice and I want to keep it, it'd be a good wall tester. Isn't going to quite meet the purpose for what I need it for. Okay, well, I guess now it's take out this old fuse holder. Desolder these wires and put in the new one. Should be relatively simple. Well, I thought I recorded that last segment of me getting this thing replaced, so I guess I did not. But you know, I bought several pairs of hemostats a while back, and they actually came in handy holding the wires to the terminals, so I could go hands-free with the solder and soldering iron. But probably wondering, now what's the point of replacing it? Couldn't you just, you know, super glue or two-part epoxy these pieces together to make a solid fuse holder? And you know, I would be inclined to agree in a pinch if there was an emergency need. Yeah, you definitely could just glue these pieces together and have a workable fuse holder. But to what end? You know, keeping safety in mind. It will no longer be as strong as it was a solid piece of plastic type material. Risk of failure in the future, and anything coupled to your mains power is a safety risk as it is. So kept it off. But if I recorded it, there was this little shim, this white one here. It was on the inside of the old one. I repurposed it for the outside of this new one because the diameter is a tad bit smaller than the old diameter, so the hole inside the chassis is a little too big, would have left too much open space. So I kind of wanted to repurpose that shim on the outside. But anyhow, so those can be set aside. I guess I could just go ahead and check the fuse itself. It doesn't look blown. And we got continuity. There you go. Or are you expecting a beep, beep, beep? Let's try that. There you go, beep, beep, beep. What type of fuse is this? Probably, if I had to guess, 250 volt, 10 amp or something. I just see 5 amps stamped on it. But no other markings. Weird. Usually you get your voltage reading. I'm willing to believe that this is probably a 125 or 240, 250 volt 5 amp slow blow fuse. Oh, I could be wrong though, it could just be fast. Might not be slow blow, but I would assume it would be. The inrush current would cause a standard fuse to blow, I would think. But right now, between here and here, it should be open until I put that fuse in, obviously. So let's get that fuse in there, make sure we got good contact. And we do. Yeah, 0.1 ohm resistance on through my leads. So we're about what, 0.2, 0.3 there. It's perfectly fine. Okay, let me get this put back together and get it plugged in and run through a test again. Well, I got it all back together and plugged in. Let's turn it on. See what we're getting now. Yep, 121.3. Cool. Well, on this other plug. Hopefully this isn't a mislabeled. 120 on one side, 240 on the other. And it's not. They're both 121. That's good. Cool. Now plug in the Variac. All right, let's set some things up. All right, isolation transformer to the wall outlet, Variac into the isolation transformer, dim bulb tester into the Variac. This on. Let's turn this on. Let's go ahead and turn this on. And we'll start increasing the Variac. Maybe we're around 10 volts or so. Starting to get power. That AC voltmeter is not picking up anything. But my flute meter is starting to pick up 22 volts AC. Picks up around 40, 41. Flute meter is saying 26. Might just be too low to detect. Either that or it's just way off. 41, 53. It looks like it's just way off. 63, 57. 98, 96. Yeah, it's not very accurate in the lower voltage scale. That's gonna have to be something I'll remember. Let's see if I can get them both in the shot. So we'll go all the way up to 120. So we're a volt or 2 volts low at 120. I'll remember that. Dropping this down. Staying about 2 volts low, 1 to 2 volts low. 5 and 7. Predominantly holding true. Around 100 volts. Yep. 2 volts low. It was reading high at that lower range. 92, 91, 89, 7. Figured it would close the gap at that lower voltage. Yeah, but once you drop below, what was that, 70? That's when it starts reading higher than the fluke meter. 69, 68, 65. So I'm going to say this right here is not good for anything below 70 volts AC. I'm going to have to keep that in mind. And then we have a 2 volt deviation. From 150, upwards of 100. Up to 130 now. $140. This Variac's only supposed to go up to 130, but seems to be maxing out there at like 145. Okay, so we are obviously this guy is it's not going to be super accurate. It's not a no specific metrology certifications or stamps or anything on it, but it'll at least serve a purpose. And I can write a note on it. Not good, 70 below, minus 2 volts, 100 or greater. Let me write that in real quick. All right, so just made myself a little annotation on there. Not good, less than 70 volts. Greater than 100 volts, you're looking at minus 2 volt deviation. But I think it's going to serve its purpose. He's giving me a readout. Now I can sit in my chair with everything plugged in and not have an issue reading a display. So just as another demonstration, again, same previous setup. Now I got this reproduction radio, replica radio plugged in, transistor based. Not sure how it's going to handle all this, but before I turn it on, I'm just going to go ahead and see if I can get that voltmeter up there to pick up on 70 volts, because I know that's where it starts to get slightly accurate. 74, 75 is good. Not sure how this radio is going to handle that low voltage. It's going to try to draw more current to power on, but
refrigerator trucks, sometimes weeks before they
huh.
get the rest. And then the average funeral cost is over 10 grand. They're not that kind of money. Just
Interesting.
Everyone has the right. An affordable burial policy can be had for as little as $1 a day. Call Final Expense Network for a free quote. They shop for affordable rates from brand name companies, folks you've heard of. One call and you get coverage to finish well. You can even name your church as a beneficiary. Come on, you have loved ones. Don't leave them at the last hour of their need. Call now, 800-589-0470. That's the Final Expense Network at 800-589-0470. Finish well. Make a quick call to 800-589-0470. 800-589-0470.
In times of economic uncertainty and chaos, your money means nothing. You may not even be able to get it from your bank or ATM. And the money you have in the stock market will go down and down. What you can bank on is
Yep, you
gold
will
and silver.
in today's
Gold and
economy.
silver have been a reliable and trusted form of currency for thousands of years. Gold and silver have never been worth zero, and typically gold holds its value during economic turmoil. Call the gold hotline now and learn how to protect your money.
You can start to hear that struggling,
And learn how to set up a new IRA or
that lower voltage.
into a gold-backed IRA. Protect your money from the next market crash with gold and silver. Call now for
I
your
suspect
free
it would
gold
be.
guide. 800-281-4222.
Well, awesome. Again, I'm happy with this. Super happy. I like it, and I like it a lot. Well, that's going to do it for this video. I guess a small repair in there on the isolation transformer, but at least you get to see a setup between an isolation transformer, a Variac, and a dim bulb tester and a demonstration. This is definitely going to come in handy later on when I start restoration on the Zenith radio. Went ahead and actually wiped it down a bit because it's super dirty, and when I start to work on it, I don't know, I'm probably gonna be wearing gloves, to be honest with you. But you know, how did that fuse holder break? Maybe in transit or something while it was being delivered. Did it get dropped? I didn't see a whole lot of damage on it, but anyways, if you found this content enjoyable and liked this video, please consider subscribing to this channel for more repair and electronics video content. Not just electronics, but other things. I mean, you can skim through. My kids have been begging me for another STEM video here, so I need to get one of those lined up. Might do a make a rocket, not fusible propulsion type, but water-based type, using a 2-liter. Might make a video on that. But anyway, sorry, rambling on. Please consider subscribing to this channel. Also consider giving it a thumbs up or thumbs down. I'm not gonna hurt my feelings. All feedback, it's good feedback in my opinion. And feel free to leave some comments or questions or anything down in the comment section. More than happy to converse with anybody while I have the time. And if you want to know how to get a hold of me outside of YouTube, what runs across every opening on my YouTube channel is my Google site, which will have the Having Fun Repairs email address on it. So there's that avenue as well. I have received a few emails in the past, people looking for some help on some things, and I have tried to reply back to be a help to those individuals. But I will say it is hard to almost impossible to troubleshoot over email when you don't have a device physically in front of you to take a look at. Yeah, I'll put it that way. But anyways, thank you for your time. Take care. Goodbye.
Bark?